Hi everyone, thank you for watching this presentation for the research breakout session on social AI in the Digitalizing Stockholm 2023 event. My name is André Pereira and I will be presenting our Digital Futures research pair project on using neuroimaging data for exploring conversational engagement in human-robot interaction. The project team now consists of 4 people with 2 members of KTH, myself, one of the co-PIs of the project, the PhD student Ekaterina Torubarova, and 2 members from Stockholm University, Caroline Arvidsson, another PhD student, and Julia Uden, also a co-PI. So in this project, we are exploring the strongest traits from each research group involved. Stockholm University investigates and analyzes communication and language using human brain imaging. And at KTH, we are responsible for developing and evaluating the interactive technology for social robots. Of course, we work together on all of these things, but this is the specialties from each of our research groups. So one of our main objectives is to use fMRI to study both humans and robots in conversations. Exploring fMRI in human-human real-time conversations is actually still rather unexplored territory. And another goal of our project is to study the underlying neural signatures of the still very subjective term of engagement. And in human-robot interactions, it has been shown that better engagement with robots can, for instance, lead to better pupil learning or better perceived elderly care. So it is important to be able to have an estimate of engagement in many human-robot interactions. Probably the most common methods of evaluating social robots and to analyze subjective aspects of human-human interactions have been to use subjective reports, but these have several issues. So when you're using subjective reports, you're often dealing with reports that occur after an interaction has taken place, instead of getting real-time moment-by-moment data. And these subjective reports can actually be conducted online, but this approach often interrupts user interaction if you keep asking users to give you a subjective measure. And when using questions, there is also the potential for misinterpretation because different people might interpret questions differently. And there's also some experiences that are very hard to verbalize. And of course, we can suffer from biases such as the social desirability biases, where we try to please the experimenter. There's memory bias and many other types of biases that might make subjective approaches worse. And so all of these calls for objective online measurements, such as what we're planning to do by using fMRI. After our project started, we found out a similar project to ours by Hochbauer and al. That also analyzed conversations inside of a scanner. And they also did it both with the human and with the same robot that we intend to use. We decided to start our research in this project by deeply analyzing this dataset so that we can, when collecting our own, improve on it. And similar to our proposed setup for this project, their setup contained an audio-video link between the participant in the scanner and the agent outside. There was a mirror inside of the scanner and a microphone that allowed the participant to communicate either with a human experimenter or with a robot. And our focus for the analysis in this dataset is a little bit different from what the other authors from the other dataset wanted to explore, because we want to go a little bit deeper on conversational dynamics. So in particular, using their dataset, we have investigated differences in production versus comprehension, both with humans and robots. And we also looked deeply into turn initiation, which is our mental preparation of just before when we start speaking. For turn initiation, we considered a 600 millisecond time window before every production onset. And we also looked into instances where there was overlapping and non-overlapping turn initiations in some of our analysis. And then we investigated brain imaging contrasts in these intervals related to these three conversational events on both the interactions with humans and robots. This slide presents some of the results of our human-human analysis within this dataset. In this figure in particular, we are highlighting in blue the contrast of turn initiation with the baseline brain activity. And we can see that there are many activations outside of the language network. And these results show that the 600 millisecond time window of just before speaking is a very interesting time window to look at brain processes. So we suggest that the frontal activation that we observed are reflecting sociopragmatic processes that might be involved in intention processing and attentional control. These processes are actually being hypothesized to play a crucial role in speech preparation during interaction, and we're kind of confirming that. And there's not a lot of studies that have shown activity outside of the language network taking place in actual human-human conversations, especially during turn initiations. And we have also tried to investigate how speaking or production compares with comprehension during actual conversations. And while we are not reporting here on this presentation on all the findings we've made when comparing comprehension and production, we have a preprint that is now available on bioRxiv that can be consulted if you are interested. And regarding the different contrasts we ran with human-robot results, we have found out that during listening, the robot compared to a human elicited more activation in the regions of the brain that are more associated with auditorial processes. It appears that listening to a robot then requires more processing than listening to a human. But for turn initiation, we found an opposing pattern of results. When they were preparing to speak, a human elicited more activation in both the auditory and visual cortex. So humans are perhaps planning more verbal and nonverbal turn-taking cues when picking up the turn and interacting with other humans. In the human-robot interactions, our results clearly show that participants spend different mental efforts depending on each agent, and that more effort is necessary for comprehending the robot. But conversely, more relative effort is spent on taking in the human agent, also visually, during turn initiation when compared to the robot agent. And a more detailed analysis and discussions of these human-robot results can be found in our CogSci paper. However, we think some of the findings of our human-robot analysis can be attributed to the basic Wizard of Oz interface that was used in the dataset that we analyzed. This dataset had actually very unnatural interactions between humans and robots, where turn-taking was really different in terms of timings from human-human interactions. We are then hypothesizing that a better Wizard of Oz interface will be more representative of our interactions with robots in the future, and as such, it will be more revealing of how our brains are going to react to interacting with the robots of tomorrow. And for this, we have developed a system that uses the MetaQuest Pro headset to control the Furhat robot. By using this head-mounted display, the operator's facial expressions are mimicked in real time, and as such, they're more meaningful to decode by human participants, because the robot in the original dataset that we've been reporting doesn't have comparable facial expressions to the human experimenter. We are also using the voice of the experimenter to control the voice of the robot. And we have now a submission where we analyzed how different choices in Wizard of Oz interface actual influences human-robot conversations and human-robot interactions. So currently we are now on our way to collect our own fMRI dataset. And for this, we have developed an open conversation interaction scenario where participants discuss ethical dilemmas with an experimenter in its human form or telepresencing a robot. And for the telepresencing or wizarding interface, we are using the telepresence interface we presented in the previous slide. And this will also allow us, this scenario, to study conversational engagement as we are manipulating. We are testing three conditions: one that should provide high engagement to participants, one where we're going to provide more medium, and one where we are trying to simulate a lower level of engagement to be able to study this phenomena. And one of our main goals is also to provide a new data set for people to be able to study the brain in actual conversations, both with humans and robots. Thank you for listening to our presentation, and please don't hesitate to contact us about our project.